toward an efficient and effective recommender system development. I am Kubo from the Machine Learning Solution team. This is the agenda of this presentation. First, I will give an overview of LINE's recommender system. Then I will talk about the challenges we want to overcome and discuss masala, which provides the ability to solve them. Section 3, 4, and 5, I will explain what we need to be careful of in each phase to effectively develop a recommendation engine, and talk about functions of masala to follow up on them efficiently. In part 6, I will share a case study and finally conclusion and future work. First, here's the overview of LINE's recommender system. LINE uses recommender systems for various services. Also, there is not one recommendation frame for one service, but there are various frames for displaying recommendations, such as the recommendation frame displayed on the HomeTab of LINE app and the Smart Channel frame displayed at the top of the Talk tab. As for the features, purchase history, clicks, view, and other features unique to the service can be used, and there are many options. Based on these backgrounds, there are some challenging issues. First, developing many recommender systems is very costly. Then, we want to simplify the development, but we have to have good business effects, which requires high quality. In addition, the hurdle of quality becomes higher as it improves. Regarding these two issues, the latter is particularly important, and even if the development cost is high, no matter how easy it is to develop a low accuracy product that does not deliver results, it is not competitive and does not contribute to the business. The development will be inefficient because it involves a lot of people for A/B test. In other words, I think it is important to develop efficiently under the constraint that it must be effective. In order to achieve this, it's important to know the baseline to some extent at the time of offline testing, find its weaknesses, evaluate it correctly when creating a new model, and immediately know the right direction to go. In order to carry this out efficiently, masala offers various functions. Bias reduction in dataset for offline testing, appropriate handling of data leakage in dataset construction and training, flexible feature setting, continuously improved recommender engine served as a baseline, various offline evaluation metrics that give a multifaceted perspective, demodes specialized for each service. Masala provides necessary functions to improve effectiveness. I'll talk about each of them later. Now, I would like to briefly introduce masala. To put it simply, masala is a config file-driven ML task collection. Here is a diagram of the overall flow of masala. I said masala is a ML task collection, and this task collection is controlled by masala controller. It receives a config file from the user that contains the task settings, and masala controller checks the config file if there's any mistakes. Then each task is executed according to the task flow. Each task builds, trains, and predicts datasets and writes the results to local or other storage. That is the brief explanation of masala. The main focus of this presentation is composite task recommendation baseline of masala. A composite task is a mechanism to execute multiple tasks with one task. It automatically generates a config that executes other tasks internally, writes it to storage, and refers to it to execute other tasks. By writing the config to storage once, you can change the configuration a little later and run each task separately. An example of that would be changing learning parameters. The composite task recommendation baseline runs the dataset constructor, baseline methods, evaluation, and demos all at once using the function I just described to improve effectiveness. This allows you to start development efficiently and quickly. In this presentation, I would like to touch on the things you should be careful in each phase of the development of recommender systems and explain how these tasks follow up on them. First, let me talk about dataset constructor. In the dataset construction of recommender system, training set, prediction set, validation set, and evaluation sets are constructed. Here, the validation set means the data that is not used for evaluation for determining the number of trainings and hyperparameters. The training set and validation set are split to be mutually exclusive so that they don't contain the same data. Also, the evaluation set uses the behavior history of future users, but the actual production environment does not have future behavior history. If it is necessary to determine the number of trainings with the validation set, the validation set will be constructed from the latest behavior history. In addition, when evaluating with the evaluation set, the behavior history of the validation set can be used as a feature at the time of prediction. So in that case, the validation set is also used for prediction. We talked about recommender system datasets, but is it really okay to simply split them up and evaluate? There are some things to consider when splitting datasets. That is bias. Most recommender system datasets lack user-item interactions for some reason. For example, there is a popularity bias that products are not listed in the popularity ranking are likely to be missing. The characteristic of such datasets are called MNAR, as they are missing not at random. A dataset with such bias cannot evaluate recommender systems correctly. Missing at random is desirable. This is called MAR. There is also a way to build a MAR dataset by randomly showing the product to the user, but it is very costly and impractical. Bias must be reduced from the MNAR dataset for precise evaluation without spending a lot of money. Techniques for bias reduction are weighting and sampling. With weighting, the more the item is recommended in a current system, the less the impact on the evaluation. The pros is that it can reduce various biases in the current system. Cons is that the recommendation score cannot be expressed with probability, or it is difficult to apply in some cases like an ensemble recommender system. With sampling, minor items are sampled with weights that are inversely proportional to the frequency of the items to create a MAR dataset from the MNAR dataset, and evaluation is performed accordingly. The pro is that it is easy to apply in various cases, and the cons is that the current study can only reduce the frequency bias. Also, in our case, we need to consider not only the bias, but also the characteristic of display frame. In the official app, the recommendation frame is displayed to the users of the app, so it is preferable to sample users from heavy users to light users in a well-balanced manner. In addition to the recommendation frame, there are various other frames such as popularity rankings, so differentiation is necessary. Therefore, better item sampling would be to focus on minor or niche items that match the user rather than just popular items. In the case of Smart Channel, better user sampling would be a balanced manner just like the official app. On the other hand, Since there is no other frame of the app, there is little meaning to differentiation. So it is preferable to sample items in a well-balanced manner with popularity and minority. In HomeTab, unlike the other two frames, it is displayed even if the user does not use the app. So light users and users who do not use the app, called cold users, are focused when sampling. On the other hand, as with Smart Channel, items have no other frames in the app, so it is preferable to sample in a well-balanced manner. We pay attention to the bias I talked about earlier and the characteristics of display frame when we construct an evaluation set. In masala recommendation based on Carollo's sampling logic for bias reduction, it provides alpha and beta parameters that smooth the frequency so that you can adjust whether it is minor or balanced for each frame. With this formula, if the probability of appearance is lower than that of hat P with evenly given probabilities, that is, if it is minor, then the weight is increased when sampling. Figure 1 shows the sampling configuration in masala. You can configure the sampling conditions like this. Whether or not these values are appropriate is determined by actually looking at the correct answer data sampled in the qualitative evaluation demo, which I will introduce later, and checking if there are many items that you'd like to recommend. In addition to weighted sampling, items that are simply too popular may not fit the recommendation rating, so they also have the ability to exclude the top N items. With this simple configuration, you don't have to re-implement tedious sampling for proper recommendation system evaluation. Another thing to be aware of when constructing datasets is data leakage. Data leakage makes training program problems become easier and makes test problems difficult. Thus, accuracy goes down. For example, when building a validation set targeting the purchase of manga, the correct answer is sampled from the purchase history. On the other hand, if you do not remove the sampled manga from the browsing history, you can always get hints during training. And the actual test without hints will be difficult to solve, so the accuracy goes down. It's easier if you have a small number of features, but an effective recommender system often puts a lot of features, which makes it cumbersome to remove this leakage. Therefore, in masala, by setting the category as shown in Figure 2, the relationship of data leakage is derived and automatically removed. For example, in the case of Figure 2, when paid comics is the sampling target, the sampled product ID is also removed from paid read comics that has the same category. Masala can also handle a list of meta information called metas. Again, masala removes the authors and magazines that correspond to paid comics to prevent leakage. Like this, without writing a complicated process of leakage removal, you can efficiently add many effective features just by adding a category to the settings.
Next is evaluation metrics. So effective the recommender systems development, we need to understand the trend and the weakness of the existing recommender system. To identify those weaknesses, masala offers various indicators, and against the recommender systems, we can deepen insights against those recommender systems efficiently. There are two types of evaluation, qualitative and quantitative. First, quantitative evaluation. In masala, there are three types of performance evaluation measures are available. Performance and aggregate the diversity showing a variety in recommendation system, and individual diversity showing a variety by individual user. Today, I'm not talking in details, but indicators like recall or NDCGs, if the values are high, it is likely to identify items calling for action for users such as purchase. On the other hand, as an indicator, the overall diversity indicator, unique and aggregator entropy exists. So these are the indicators regardless of the popular items, whether a system is recommending various items or not. For instance, the second party is offering the various items, whether the system is properly offering various items in order to invigorate that market and also let users know varieties of items other than popular items. In most cases, these are the relations with the trade-off with the performance. So when these indicators improve, the performance goes down. But that is the situation for offline testing. So in fact, there are some impacts of the diversity, better impact when we have a diversity. So we have to assess whether it is appropriate or not through the qualitative assessment. And individual diversity items will be explained in the next slide. So individual diversity, for instance, in manga, there are two types of recommender lists like this for a particular user. The user prefers horror genres, but sometimes read comedy too. On that day, whether this user would like to read comedy book or not, this is external indicator, so recommender system cannot tell. So if the user would like to read a comedy on that day, then likely to be clicked on the right recommender list. This is instinctively identifiable. And of course, a user click a certain list, then likely items will be displayed. Then the users would know that. So the horror genres can also be tracked anyway. In that case, on the left hand, the horror only type of recommender list is not meaningful. For this individual diversity in masala, as you can see in figure 4, it can be measured easily by adding the item attributes. In this table, baseline 2, the similarity of genres goes down and improves the individual diversity. If baseline line 1, genres have a lot of bias, and that is the root cause of the less effective result. If that is the hypothesis, we should think that A/B test on the baseline 2. However, whether that diversity is adequate or not, we need to perform the evaluation, qualitative evaluation. And in this evaluation test, looking at the output of the recommendation, whether this result is appropriate and diversity is adequate, and in the positive label that sampling and the evaluation set comes out, whether these are the items that we would like to recommend, we have to check that at the very beginning. Otherwise, the effort we made to improve the performance in the evaluation set will be wasted. So it's better to check at the very beginning. And also, the evaluation for the qualitative assessment can be used for the debug for the data loss, and check recommender for the minor models, minor products are recommended or not. That could deepen the understanding of the service or model. And in masala, we can check, we can label the frequency and also the service attributes of specific services. And you can check the specific products under certain conditions. So easily be checking the demo by attaching the frequency label and attributes label, so that you'll be able to see the way forward easily. Next is a model tuning, and because of the time limitations, I cannot cover all the creative ideas and want to talk about the positive negative labeling or sampling that would affect performance and diversity a lot. In masala, there are some parameters model to make the adjustment of the performance and diversity. And in that parameters, the most influential on the performance and diversity are the smoothing parameters related to positive negative sampling. Each alpha is minimal impact on the performance or diversity, but each beta would affect greatly to performance or the diversity that you should better check at the very beginning at the tuning. Hard positive sampling the value of beta goes up, then minor items like a lower frequency C would be labeled or selected as positive. Minor items means that difficult to identify whether that is a favor of the user, but those minor items will be learned as positive label, so overall diversity can improve. And also the hard negative sampling, when the beta is bigger, then the major items with higher frequency C will be selected as negative label. Major items is selected as negative label means that the major prevent bias of recommending major items a lot, so that overall diversity will improve. Actually, this is a case that we changed each beta. First, positive sampling beta is gradually changed to select minor items as positive sampling. Minor items are, every time minor items are sampled, minor items are learned, and you see the number of unique items grow. On the other hand, performance indicator NDCG is deteriorating. So in this figure, you can see that positive sampling beta is changed. You will be able to make the adjustment of trade-off between performance and diversity. And the negative sampling beta is gradually changed to select major items as negative. Then we can prevent the bias toward the major items only, and then unique items are going up. At the certain threshold, there should be the deterioration of performance by not selecting or recommending major items. Through this, negative sampling's beta value is changed so that we'll be able to adjust the trade-off between performance and diversity. And then the qualitative and quantitative evaluation, we need to identify the right landing point. So this tuning can be done automatically eventually. Finally, what we have to be careful is the model robustness. Time is over when the adjustment parameters are limited and the model was robust against data set change. So nowadays, a recommender system sensitive against data change is used, for example, deep learning with various adjustment parameters. So recommender systems, the data sets is updated every day. So the robustness must be ensured for the performance, even the data set is changed. Therefore, with the latest data set, we have to check the performance and the diversity through the, and of course, the robustness. And of course, we should not stick too much and tune all the time for the old dated data. And the service will change and users will change every day, so should not stick too much on the older data and try not to have over learning, and that will become consuming and not yielding. So masala, the configuration date setup can be changed and redo, so robustness tests can be done effectively. And this is the example of such tests compared to old data set. We ensure the performance and diversity. If we check this, then move to A/B testing. Now I covered the overall structure of the recommender system development. So I want to talk about the case example, line theme recommendation in HomeTab. In the HomeTab, there are many other service recommendations on display, but this time is an example of the theme recommendation. For offline reproduction test result, we use the data set splitting by masala. The baseline is that the various features are entered in the heterogeneous matrix factorization. And the performance indicator DC and DCG is used for fine-tuning, but we use the neural network and the aggregate entropy and all other diversity was checked and made adjustment. And the proposed surpasses the baseline in both performance and diversity. And you can see the online result by limiting the number of users. And performance indicators like CTR, CV are both increased, and also number of unique items are growing, and also the CV numbers are growing at the same time, so cannot say categorically, but this is the result of the incorporating diversity. And for the frame, this kind of improvement was witnessed, but this tended to have the cannibalization of the sales from other frames, and overall sales may not go up. Because the user have the limited budget, that happens. However, in this case example, the overall sales was net increase, and we had the differentiation and diversification, and made a good recommendation. That was the reason. And in masala, efficiency is as follows. It becomes easy to add new features within a minute, and no need to change codes considering the leakage. And easier to try in other services as well. And already existing other service configuration will be copied and paste, and replacing the features and data passes only, so that evaluation or demo can be seen. Now, conclusion and future work. In this presentation, I explained the recommender system development initiatives. And for each phase of the recommender systems, areas to be paid attention, and how we implement that in masala was explained. Impact and also the efficiency was improved in some case example. For the future work, I would like to perform the detailed investigation with online testing on performance and diversity trade-off, and development of a new recommender and recommendation and baseline to develop cross-recommendation across services. That concludes my presentation. Thank you very much for listening.